Okay, in the last lecture, we have gone through rectangular window function and we have seen due to the sharp discontinuities across the transition region in rectangular window leads to oscillatory behavior in the frequency region of the filter response. This particular problem leads to Gibbs phenomenon. So one of the way to reduce that particular problem is to use some kind of function which does not have a sharp discontinuity. One of the most peculiar kind of example which can come in our mind is triangular window. This is also called Bartlett window. Now, the causal window which can be written for both values of m, odd and even, is Wtn 1 minus 2 n minus m minus 1 by 2 over m minus 1 for n equals to 0 to m minus 1 and 0 elsewhere. Then the frequency response of the triangular window can be evaluated as W T omega equals to 2 over m minus 1 sine of omega m minus 1 by 4 over sine omega by 2 whole square. Now, as usual, we will look for two properties. First one is main lobe width. The main lobe width is equal to 8 pi by m, which is twice large of rectangular window, which was 4 pi by m. The main lobe width increases. That means transition width is also equal to 8 pi by m. It is approximately equal to 8 pi by m. Second point is peak of side lobe over main lobe ratio is minus 26 dB, whereas in rectangular window it is only minus of 13 dB. That means we have seen improvement over peak of side lobe over main lobe ratio, which is improved from minus 13 dB to minus 26 dB, but at the price of main lobe width, which also increases the transition width. Third is stop band attenuation. In triangular window is 26 dB. These are the important 3 points which we should look in every window. First, what is the main lobe width? Second, peak of side lobe over main lobe ratio. Third is stop band attenuation in that particular window. As we can see, this triangular window dominates over peak of side lobe over main lobe ratio. In rectangular window it is minus 13 dB, now it is minus 26 dB, so it is improved. Stop band attenuation is also higher, it is 26 dB, whereas in rectangular window it is 21 dB. That's mean it is an improvement. So point second and point third is improved by using triangular window, but point first is actually the trade-off. That's all for this triangular window. We'll discuss another window in next lecture. Thank you.